Hello, math humans. We're going to do 3.3 today. We're going to be talking about properties of logs. Our objectives are that we're going to talk about the change of base formula and look at that in our grapher. We're going to use properties of logs to solve equations, and then we're going to condense and expand logs either with or using our properties. So when calculators were older and they didn't have as many cool buttons as they do today, it's hard to talk and write at the same time, we used a handy thing called a change of base formula. And that said the log base A of x is equal to, so our calculator has base 10 and base e. The new graphers have this setting, but they used to not. And so we would use a change of base formula to do the calculation. So I would choose a base that I liked divided by the log base b of a that made my life easier. So oftentimes they either chose base 10 or base e. Alrighty? But that was in older days. So now we can, I'm going to show you how to do this if you're doing it by hand, and then I'll show you how to do it in your grapher. So for our first example, if I wanted to evaluate the log base 4 of 25, I used to not be able to do that in my calculator, so I had to do the change of base formula. So I like base e because I have less letters to write, and so then this would become the natural log of 25 divided by the natural log of 4. And if you did that in your calculator, if I did the natural log of 25 divided by the natural log of 4, then I would get 2.322. Alrighty? But now let me show you how to do it in your calculator. So I'm going to go to my math button, and then I'm going to go down, and then there is a log base. And notice you get this cool situation. So I could just tell it that the base is 4 of 25, and ta-da, and there I get the same answer. So now with the advent of the newer operating systems, it's really easy, and I'll just write that down. So you would do math, and then you would go way down, and you would do log base, and then you would fill in the little boxes that you get, which is glorious. So the change of base formula has a lot of different applications, but we used to have to do that when we used our graphers. So now let's talk about the properties of logarithms. And it doesn't matter whether you are using log base 10 or the natural log with e, the properties are exactly the same. So the first one is the product property, which says that the log base a of u times v is the same thing as the log base a of u added to the log base a of v. So when two things are multiplied or more are multiplied together, then that becomes addition in logarithms. And it just makes for some simplification of math possible. The quotient property says that if I have, and I'm going to switch bases because the properties are exactly the same for either base, this is the same thing as the natural log of u minus the natural log of b. If multiplication is addition, then division is subtraction. And then the power rule says that if I have the natural log of a raised to the b, then this is b natural log a. That's not a 6. I know it looks like it in my handwriting, but the exponent comes out front. And again, these particular properties make solving log equations much simpler. Before we solve some log equations, though, we're going to talk about expanding and condensing. So the first one, the rule is going to say expand, and I'm going to have the log base 4 of 5x to the third y. Okay, and I think I'm just going to turn my little phone off for today because too many people are sending me fun things. So I'm going to start with the multiplication. So this would be the log base 4 of 5 plus the log base 4 of x cubed plus the log base 4 of y. Now I'm going to manage that little guy because he's an exponent, and then he'll go out front. So this is the log base 4 of 5 plus 3 log base 4 of x plus the log base 4 of y, and that would be the expansion. Okay? It's actually pretty simple. As long as you remember that exponents can go out front, multiply means add, divide means subtract. All right, so the example 2 is also going to say to expand, and I'm going to have the natural log of the square root of 3x minus 5 divided by 7. So I'm going to rewrite this first. This is the natural log of 3x minus 5 to the 1/2 power, and I'm going to divide by 7. So in the interest of time, I'm going to manage the exponent and the division at the same time. So this is going to become 1/2 the natural log of 3x minus 5 minus the natural log of 7. And notice that the half doesn't go over here as well because the square root only applied to the 3x minus 5. All right, next example, we're going to go the opposite direction, and it says to condense, which means I'm going to take an expression that looks like this and make it look something like this. So in this one, I have 1/2 log of x plus 3 log of x plus 1. And just for the first time, I'm going to do it one step at a time. The first thing that I'm going to do is I'm going to manage my exponents. So this is the log of the square root of x, because x to the 1/2 is the square root of x, plus the log of x plus 1 to the 3rd. Now I'm going to manage the plus, so this is the log of the square root of x times x plus 1 to the 3rd. And that was pretty easy. The next example, example 4, is also going to say to condense. All right, then this one's going to say the 2 natural log x plus 2 minus the natural log of x minus the natural log of y squared. All right, and I did this primarily to illustrate a point. When I have division, there is only one dividing line. So I'm going to manage the exponent and the division all at the same time. So I'm going to write the natural log, and I'm going to draw one line. There's only one division line. Anything that's positive stays in the numerator. There's the squared. Anything that's in the denominator is here. And I guess my long line looks really silly. So this is just the natural log of x plus 2 squared divided by x y squared. Alrighty? So when I have multiple things that are divided, everything that's divided just goes in the denominator. Okay? All right, I'm going to do example number 5. And it's going to say condense as well. That seems to be a little bit harder than expanding. This one's going to be 3 natural log x plus 3 minus 2 natural log x minus the natural log square root of y. And again, it's the same basic idea. Let's just add something else. Let's add natural log of x plus 4 in there as well, just to keep things entertaining. So I'm going to have the natural log x plus 3 to the 3rd, and then I'm going to have x plus 4. I'm going to have one dividing line. I'm going to have x to the 2nd and the square root of y. So it's really pretty straightforward in that anything that's multiplied goes in the numerator, anything that's divided goes in the sorry, brain fart, goes in the denominator. There's only one fraction. There are not multiple fractions. All right, you have a couple more examples. Example 6 is going to say find the exact, and remember when you see the word exact, that means no grapher. I'll just write that down in case you had a brain fart and forgot. Value. The function is going to say the log base 5 of the cube root of 5 is equal to x. Because the problem is in log form, I'm going to go back to exponent form. So this says 5 to the x is equal to 5 to the 1/3, and this is the first, 5 to the x equals. The third root is written as 1/3. I get x is equal to the 1/3. That was pretty easy. All right, next example. Is it the last example? Woo-hoo! Last example. Got excited, I can't write. This one says find the exact keyword value, and I have the natural log of e to the 6th minus the natural log of e to the 2nd. So before I get started, I'm going to put an x in there because that's going to make solving the equation easier, but I'm going to use my properties first. This is the natural log of e to the 6th divided by e to the 2nd is equal to x. This simplifies to be the natural log of e to the 4th is equal to x. Now I can say e to the x is equal to e to the 4th. It's a good thing it's the last example because I can't write. And so I get x is equal to 4. All right, my dears, that is it for today. I will see you soon.